Okay, great. So our next speaker is Tatiana Cucu, and she is from RIC and will be speaking to us also about beer profiling, but a different type of beer.
Yes, indeed. I hope you hear me well. Yeah, it's nice to hear that we have quite some talks today about beer, which is not strange, right? We are really proud here in Belgium with our beer culture. And of course, we have very special beer. We have the lambic beer also, which is typical for Belgium here. But today I'm going to talk actually about the lager beer profiling, flavor profiling with steel bar sorptive extraction and GC times GC separation and time of flight mass spectrometry. In the presentation today, I'm going to shortly talk about the importance of aroma and flavor analysis. I'm going to show you some of the methods and materials I have used for this study, show you some very interesting results we had in this analysis of the lager beer, and also some conclusions. So when it comes to aroma and flavor analysis, why is it so important? Well, it is important because through analysis of aroma and flavor, we get to know our products better. And generally, we tend to believe that products which smell and have good taste are of better quality than products which are not smelling that well. Additionally to that, for the food producers, for the beverages producers, it's very important to determine the aroma profiles of their products, of the raw material, to check what is the aroma profile during storage. Is there any loss of aroma during storage or not? And also when it comes to key aroma formation, this is also very important to be analyzed, such as in the case of cheese production or wine maturation, or imagine coffee roasting. But of course, not only key aroma compounds or key aroma flavor compounds are present in foods. Sometimes you can also have formation of flavors, often at nanograms per gram level, so PPT level, and their control and their analysis is also very important in food and beverage industry. One additional thing is that nowadays aroma profiling is very often used in food adulteration control. There are several studies which have shown that actually through the aroma profiling we can distinguish between a genuine product and a counterfeited one. Now, when it comes to profiling, what do we actually want to do? We don't try to analyze a small group of compounds. What I say typically is we don't want to find the needle in the stack. We actually want to know the whole composition of the stack. We want to know as much as possible of our compounds. So we want to do a full and targeted screening of the samples that we are analyzing. Now, beer aroma and flavor profiling is very important. At the same time, this is quite challenging. And why? This is mainly because we have compounds present which are having a broad volatility and polarity ranges. We also have compounds which are present at the broad concentration ranges. Let's not forget we have compounds which are present at ppm levels, which don't really have an important sensory importance, so they are not sensory important, but we have compounds which are present at PPT levels, and these are those compounds which often have a very big impact on the quality or on the overall aroma of the products. Now we know that actually differentiation of special beers, such as for instance Trappist beer or fruity beer, it's relatively simple. But how about lager beer? Because we know, first of all, lager beer is the most produced type of beer worldwide. And it's not only the most produced, it's also the most consumed beer worldwide. And the difficulty there is that their aroma and flavor profile is more uniform. So actually, it's more difficult to find differences between the different brands, different producers, different countries, and so on. But this analysis of lager beer is just as important as it is for any other types of analysis, because the producers need to be able to guarantee quality and also consistency, flavor consistency, batch to batch, year to year, and so on, right? And of course, when it comes to aroma analysis, sampling is very important. Steel bar sorptive extraction has actually proved on many occasions to be one of the most suitable techniques for the analysis of aroma compounds in especially liquids of beverage samples. Why is that? This is simply because there is a higher volume of extraction phase, in this case PDMS, which is giving a higher recovery of aroma compounds, especially compounds which are present at trace levels, for instance, compared to SPME extraction techniques. Now, a couple of years ago, we have already done a study in which we did beer aroma and flavor profiling, and we did that through 1D analysis. And back then, we saw that simply switching from a single quad analysis to a single quad detection to a time of flight detection, time of flight meaning higher acquisition speeds, meaning more untargeted information, we got to gain a lot of knowledge about the aromas in the lager beer. And just to illustrate you that, I'm going to check if I can get my pointer. Okay. What we saw is that, for instance, when working at 5 scans per second, which is typically the speed we use with single quad analyzer, we are able to detect the 2-decanol, which is an important aroma compound, but we are not able to detect the methyl salicylate. This is also a very important aroma compound in beer. It's only when starting to analyze samples with an acquisition speed of 10 or higher that we could identify a second compound next to the 2-decanol, namely the 2-methyl salicylate. So actually, we could gain almost 2 times more information just by simply switching from a single quad analyzer to a TOF analyzer. Additionally to that, it's even getting better than just doubling the information. It's because often in an apparently one single TIC peak, we are even able to deconvolute and identify 3 different compounds. And these compounds you see have only milliseconds apex difference, right? So here in this peak, we were able to deconvolute and identify 3 compounds, namely 2 important sesquiterpenes and 1 ethyl ester. So back then, when we did this 1D study, we have created a database of more than 400 compounds in lager beer, and most of the compounds have been identified, but I must also admit that several compounds were tentatively identified. And these compounds that we have identified were coming from different chemical families, ranging from alcohols, esters, acids, sulfur compounds, phenols, monoterpenes, sesquiterpenes, and so on. And additionally to that, back then we could nicely differentiate samples, so Dutch beer from Belgian beer, and even within Belgian beer, we were able to differentiate different producers, in fact. And in the Dutch beer, we were able to differentiate between the production site, which was production sites in country 1 and country 2. But can we actually achieve more than that? That is the question. And of course, we know GC times GC is giving us increased peak capacity, meaning more resolution. We also know that the time of flight mass analyzer is also giving us better sensitivity. And due to the faster acquisition speeds, we are able to get sufficient data points for quantification, and also we have better deconvolution. Now, in this study, we have used the LECO Pegasus BT 4D with the cryogenic modulation, and also we used initially the Chromatoph software to do the data analysis. The samples that we have used are again the same samples that we used in the 1D study. This time, both 2 years later, of course, also making sure that they were fresh. For the extraction, we just used 10 milliliter of beer, which was extracted with SBSE bar for 2 hours at room temperature. We did a thermal desorption from 30 degrees to 280 degrees, and compounds have been cryofocused at -40 degrees before being injected on the analytical column. When it comes to column combination, we have just used an HP 5 ms in the first dimension and a 17 ms in the second dimension. You see here some of the general conditions. Maybe most important to know that the modulation time that has been used there was of 5 seconds. And then when you will look at the profile of the beer that we got, you will see that we have hundreds and hundreds of compounds that we detected back there. When we will zoom into a small region here, you will see indeed what I said in my introduction. We have compounds which are present at ppm levels, and that will be these ones here, those ethyl esters there. And we have many other compounds which are mostly present ppb and ppt level. But let's look a little bit more into details. What we did, we actually first of all did just the deconvolution of our data. And what you will see is that when we compare the 1D data with 2D data, we have about a factor 10 more information back there. While we deconvoluted about 2,500 compounds in the data generated in 1D, we had about 20,000 compounds deconvoluted when we did GC times GC. Of course, these are deconvoluted data. We go a step further. This is deconvolution and identification. We narrow it down to about 300 compounds in the 1D data, and we have about 3,000 compounds with the GC times GC. So again, about fold 10 more information just by switching from 1D to 2D. And again, here we looked at what does it give the impact of doing RE, looking at the REs or not. But actually, by looking here that we have about 10 times or 10-fold information increase, it's actually in line with what has been previously published. Back in 2008, Bloomberg, and also in 2015, Matthew Klee, they have published some interesting studies in which they said that theoretically, GC times GC has the potential to achieve about 10-fold peak capacity gain. So actually, this is what we have seen with our results. But let's look a little bit deeper in that. What we had in 1D analysis, for instance, here we had a region where we nicely could deconvolute and identify dimethyl disulfide and pyridine. When we did GC times GC analysis, we actually identified a new compound, which is the 2-butanol 2-methyl. And this is an important compound because this compound is having a fresh, fruity, pulpy almond flavor. So this is a very important compound to know about in our beers. We go further, we see another compound, which is a damascenone type of compound, which has not been previously detected in our data, 1D data. Also a compound which is known to have a green tropical flavor. We have also identified caryophyllene, which was not previously identified. You see here we have 3 almost co-eluting compounds in our 1D data. Caryophyllene was one of which we were not able to identify earlier. But actually we had even regions in our chromatograms where we have even identified 3 completely new compounds which were earlier not identified. And these are compounds which are having very important aromas. So we have the methylvanillin, masoialactone, and alpha-murolene, which is a sesquiterpene. As sesquiterpenes, these are very important flavor or very important compounds which are coming from the hope. So often related to the quality of the hope and stuff like that. We saw here 2 other important sesquiterpenes which we have identified in GC times GC data, which were not previously seen with 1D data. But let's look a little bit more into details in group of compounds. So let's look at the ethyl esters. Ethyl esters are very important compounds in beer. And we see here, in fact, we already identified quite some ethyl esters previously, but now we have identified 3 additional ethyl esters in our samples. You see here nicely the extracted ion chromatogram of over Z88, which is typical for the ethyl esters. And you see the nice distribution of all the linear and branched ethyl esters. And in fact, when we look at the group of gamma lactones, we have almost 2 times more information, 2 times more lactones detected in the GC times GC data compared to 1D data. Now, sample differentiation for us is very important to know whether we can differentiate between brands, can we differentiate between countries, can we differentiate between producers, and so on. And you see here a very small table where we can definitely observe differences between the different samples. And we have compounds in which, like hexanol, which is very abundant in the beer 3, Belgian beer 3, which is from another producer, and less abundant in the other samples, and so on and so on. But the very important thing is to see that when in 2 years ago, when we published our data, we have proposed some markers for the different brands of Belgian beer, and back of beer. And back then, we have seen, for instance, that the methyl acetate has been present or most abundant in the Dutch beer from Netherlands, and then a little bit less in the other types of beer. And these data have been reconfirmed with the GC times GC data, indicating that actually the markers that have been previously suggested are still valid, but probably with the new data, we will be able to maybe find newer, more selective, more or better markers for the different beers. So now, what are we still doing now? We are exploring the tile software in which we are trying to dig further in our data. So there's still quite some work to do in terms of data analysis. We are looking compound for compound and look at the trends between the different samples. Still on the, there's a little bit shift in my slides. Anyway, what I could still see in my results is that I could still differentiate the different Belgian producers and from the Dutch producers. So that was some data created with the non-curated, some results created with the non-curated data. So the trends that we have seen previously with 1D data are still valid, but I think the information that we get is much more extensive. Now, in conclusion, we can get in-depth data flavor profiling of Belgian and Dutch beer, probably of any other type of beer, using SBSC, GC times GC, and TOFMS detection. SBSC is very interesting. Why? Because it's environmentally friendly, it's reproducible, and it allows to differentiate closely related beer types. Now, the information that we get via this technique is actually something that beer producers could use to optimize their ingredient selection, to optimize their processes, to also find, for instance, which are the optimal storage and packaging conditions. But it's also something that can help beer producers to tackle the new emerging issue of adulteration, right? And let's not forget something else. We have a lot of mini breweries in Belgium, but I think everywhere in the world. And those guys, they cannot have a fancy instrument such as GC times GC TOFMS. It's just impossible to do that. And in fact, SBSC extraction is something that we can see as an on-site extraction technique, and later on something that can be analyzed, in fact, in more specialized laboratories like this, giving also the opportunities to the smaller beer producers to, in fact, determine the aroma profiles of their own beers. Voila, and that was my presentation of today. If you have any questions,